Good morning, Michael.
Good morning, Matt.
I see we have some very interesting title here. The possibilities are limitless. Takeaways.
Well, we've done this whole video course about calculus, and I think we want to wrap up by saying, what are maybe 3 big takeaways that we want people to come away from?
One of the things that I really appreciated working with you on this, and we did this really together, joint project, was the fact that we used geometry. So geometry to motivate and to visualize a lot of the ideas, some of which were fairly challenging.
They were challenging ideas, but I think you're right. This is a big takeaway. Is a lot of the stuff that we did in calculus, we motivated by pictures. So you need to know how to graph a few things. But for instance, we were showing how if you start with a circle, you come up with a sine function, cosine functions, all the properties of sine and cosine. Same thing for the hyperbolic functions, hyperbolic sine, hyperbolic cosine. We worked with a hyperbola. We had a different hyperbola to get the exponential function and even the logarithm function. So all these things were geometric. They weren't algebra. They weren't doing a bunch of calculations saying, let's look at a picture.
And in addition to that, the actual geometric intuition that we got from the circle transferred almost 1-for-1 to the hyperbola in terms of the concept of how to use areas rather than angles.
Exactly. And what we found really interesting is these pizza slices on the circle, you can change to sort of warped pizza slices in the hyperbola. And that was a key to getting all the properties of the hyperbolic functions.
And that led us to what I think is that what I see is the second takeaway, and that's approximations.
Exactly. Approximations. And I really like this idea because it sort of removes some of the mysticism of calculus. Like a long time ago, people talked about infinitesimals. And I guess Newton had his idea of fluxons. And there was all these sort of strange things moving around or being smaller than any real number, but still bigger than 0. Very strange. We just came up with a concrete idea of an approximation, made that precise with our error functions, and then we were able to do all of calculus.
And what I really like about this takeaway is that it is extensible to higher dimensions.
Exactly. Now, we haven't talked about that, but calculus can be done in 2 dimensions, 3 dimensions, actually even infinitely many dimensions, which is a strange idea, but you can do that. And this approximation idea carries on exactly the same way, even to the point of doing derivatives in higher dimensions.
And finally, the third takeaway is we have made a complete approach to the basic content in our first-year calculus course that talks about derivatives.
So let's put that down. Complete approach. Do we want to say complete approach or complete course?
No, let's say approach.
Okay.
Like 1 and 2 encapsulates an approach.
And we did try to show this in the video series. We showed how you can define things like derivatives. Higher order derivatives can be defined in a similar way. We get approximations of higher order, like in the Taylor polynomial approximations. We did our sines and cosines, hyperbolic functions, exponential functions. Very much a complete approach. We even did the funny things like, what was it? L'Hopital's rule.
Oh, L'Hopital's rule was a real challenge.
That was a challenge.
As was the exponential, because we had to do all the geometrical work. So onwards and upwards, congratulations on this work together.
You know one thing we forgot to mention?
No.
If you want more details, we have a paper written about this. It's published on the archives. You can see it in the comments of the YouTube video.
Okay,